So to help you with your visualization and 3D or geometric intuition, we jump back to section 13.6 to cover cylinders and quadric surfaces. So these are not functions, but they are surfaces, and learning how to graph or visualize or sketch them will help with what we're doing back in chapter 15. And sometimes this section gets skipped, so we pick it up now. So to begin with, let's define a cylinder. So a cylinder is what you get, is the surface that you get when you take a plane curve and you pass a whole bunch of parallel lines through it. So it's formed by parallel lines passing through a line curve. Oops, not a line. A plane curve. No such thing as a line curve. All right, so for example, maybe you have like a parabola like this floating in space, and then you take a line like this one, and then you take a whole bunch of parallel copies of it and attach them to all, so it looks like they're passing through that plane curve there. And you get this like rain gutter shaped kind of thing flying through space here. Infinite rain gutter, goes on forever in both directions, and so on and so forth. Now I've drawn this one all sort of cattywampus, so it's like angled, hanging out in 3 space, going kind of wonky. But actually for this class, all the ones you're going to see, the parallel lines are going to be extended in some direction parallel to the basic coordinate axes. And that'll make it easier to visualize and also to see what's going on just from the algebra, from the formula. So okay, so there's an example. Now let's look at how this comes from an equation. So if we have x squared plus y squared equals 4, and you're asked to graph this, actually what you're asked to graph is the collection of points x, y, z in R3 such that the first coordinate plus the squared plus the second coordinate squared is equal to 4. And the first immediate thing that you notice is that here we're in R3 and there's a z coordinate, but the condition over here, there's no constraint on z. So that tells you that your surface is going to extend vertically. Because there's no constraint on the z bound. Okay, so let's see. So we would set up our axes. So here's x, and here's y, and here's z. And so if I do the standard thing and pick like, hey, let's see what's going on in the xy plane down here where z is equal to 0. And then I sketch that, or I just stare at it and go, oh, x squared plus y squared equals 4. I know that one. That is a circle of radius 2 centered at the origin. So it's going to be that circle right there. Not the inside of the disk, just the boundary of the circle. And then if I were to sketch it again, actually, you know what? I deleted that plane, but let's take it. Let's take the whole schmear. So we've got it with the plane, and I'll even grab a copy of these lines that I had floating around in the back to visualize the plane a little bit better. So I'm going to take this whole thing and just say, oh, you know what? If I were to redraw this figure at height 1, so up here somewhere. So that's the plane z equals 1. It would look all exactly the same. So in other words, I'm getting the same kind of surface that I get if I were to make a vertical line coming through every point of this circle here. and I'm sure you get the idea. We have a circular cylinder extending upward and downward forever. Okay, so that's probably good enough to visualize what's going on with this surface right here. So this is a cylinder, and it is a circular cylinder. Whoops, circular. And let's do another one real quick. So if I asked you to sketch z equals x squared, then actually we're looking for all of the x, y, z points in R3 such that the third coordinate is equal to the square of the first coordinate. And once again, you say, oh, we're looking in R3, but not all three coordinates show up over here. We have no y. And then that tells you that it's going to extend in the y direction. So let's see. So, and like I said, cylinders can go in any direction, but in this class, we're only going to do ones that are parallel to the x, or to the y, or to the z axis. And so this one's parallel to the y axis, so I can start by checking out what goes on in the xz plane, aka y equals 0, and then just extend it outward from there. So let's see. So z equals x squared, so it's going to be a positive opening parabola in the z direction. So there's my parabola. And then I'm going to draw parallel lines through it that are parallel to the y-axis. Oops, I went a little far with that one. There we go. And stitching all those together, I should end up with another one of these rain gutters, something like that. So this would be a parabolic cylinder. And that's about all there is to cylinders.